Hey, welcome to my channel Industry 4.0. Linux containers are movable and reliable. They move from development to testing and lastly to production. This creates them much faster to use than development pipelines. Today, in this video, we would understand the Linux containers in detail. Please like and share the video and subscribe to my channel. So, let's start the video. Introduction. Fresh containers started in the Linux world. They are the product of a huge amount of work from an extensive range of people over a long period of time. Google Incorporated is just its one instance. It has backed numerous container-related technologies to the Linux kernel. We will not have current containers today deprived of these and other contributions. Linux containers are movable and reliable. They move from development to testing and lastly to production. This creates them much faster to use than development pipelines that trust on replicating old-style testing environments. Containers are likewise a significant part of IT security due to their popularity and ease of use. Description. Linux containers comprise applications in a system that retain them isolated from the running host system. Containers permit a developer to package up an application with all of the parts it requires. There are examples of libraries and other dependencies. Also ship it all out as one package. They are intended to make it relaxed to deliver a reliable experience as developers. The system administrators move code from development environments into production in a firm and replicable way. Importance of Linux containers. See, we're developing an application. We do our work on a laptop and our environment has an exact configuration. Further developers can have to some extent different configurations. The application we're developing depend on that configuration. It is dependent on particular libraries, dependencies, and files. For the meantime, our business has development and production environments that are reliable with their own configurations and their own sets of backup files. We want to match those environments as much as likely locally. Then deprived of all the overhead of recreating the server environments. Therefore, how do we make our app work across these environments? The answer is containers. The container that grips our application has the necessary libraries, dependencies, and files. Thus we can move it through production without bad side effects. The contents of a container image may be thought of as an installation of a Linux distribution as it comes whole with RPM packages, configuration files, etc. Container image distribution is quite simple than installing new copies of operating systems. Linux containers may be practical to many different problems as if required portability, configurability, and isolation. Containers are vital because they're the only way to deliver the scalability an application needs. Containers act like a virtual machine. They can look like their own thorough system to the external world. Containers don't require to repeat an entire operating system. This offers an important performance boost and decreases the size of the application. A number of the technologies driving container technology are open source. It's mean that they have a varied community of contributors. That helps to substitute fast development of a wide ecosystem of related projects suitable to the needs of all kinds of diverse organizations. The Linux Containers Project, LXC. This is an open source container platform that delivers a set of tools, templates, libraries, and language bindings. LXC has a simple command line interface. that recovers the user experience when starting containers. LXC deals with an operating system level virtualization environment that is existing to be installed on various Linux-based systems. Our Linux distribution can have it available over its package repository. Docker technology. About of the most important technologies that allowed the huge growth of containers in modern years comprise kernel namespaces, control groups, Docker. Docker originated along that containers were successfully democratized and nearby to the masses. There are various operating system virtualization technologies alike to containers that predate Docker and contemporary containers. Nearly even date back to System and 360 on the mainframe. Docker was the mystic that completed Linux containers practical for meager mortals. Say differently, Docker incorporated prepared containers simple. Docker came onto the scene in 2008. The Docker technology added many new concepts and tools. It introduced a simple command line interface for running and building new layered images. Also provided a server daemon, a library of pre-built container images, and the idea of a registry server. Joint, these technologies permitted users to rapidly build new layered containers and simply share them with others. There are three main ideals to make sure interoperability of container technologies: the OCI image, distribution, and runtime specifications. Combine these specifications, permit community projects. Also allow commercial products and cloud providers to build interoperable container technologies. For more details visit https://www.technologiesinindustry4.com/2021/09/what-are-containers-in-linux.html